Now, we have discussed the first part where we have said that r depends upon velocity. In the first part, we said that r depends upon the first power of velocity, and the second part we said that r depends upon the square of velocity. This is where velocity is small, of around 50 kilometers per hour to around 100 kilometers per hour, and this is valid when velocity is around 1000 kilometers per hour for high velocities. So this we have discussed, and we have found out that the terminal velocity is mg upon b. And we have said that if something is moving, it's falling in air or in water or any other atmosphere, it will experience some opposition if it is moving in this direction. And we have solved this, and we found an expression. Now in this case also, if something is moving, let us say in air, there will be a resistive force again opposite to motion, so acceleration here. So the resistive force will behave in the same manner, but the only thing is that it will depend upon the square of velocity. That makes a difference. And r in this case is d rho a v square upon 2. So again, if we have to write an equation for this kind of motion, it will be ma will be equal to mg minus r, okay, or mg minus d rho a v square upon 2. Now again, we don't write this negative sign again here. Why? Because again r is in this direction and the resistivity is downwards. Acceleration velocity is downwards, so they're already opposite. If I write a plus here, it will mean that mg and r, they are in the same direction, but in reality they are opposite, so we have to write the negative sign only once. Okay, so this will be equal to ma. Now at infinite time, acceleration will be 0, because we know that r will be equal to mg. Resistive force will increase gradually because it will increase with velocity, and it will become equal to mg. So if it becomes equal to mg, then the velocity will be constant, and that velocity, again as we have discussed in our last case, is called a terminal velocity. So if we put it equal to 0, it means that 0 will be equal to mg minus d rho a v squared upon 2. So from here, velocity will be equal to 2mg divided by d rho a under root. So this will be the terminal velocity.